So, I recently watched this video about the use of Mathematica in terms of trying to analyze the alien language in the movie Arrival. It was pretty cool. I saw that in the video that he used a little bit of machine learning and how he tried to analyze the logograms, basically the writings of the aliens in the movie, and I was curious to try Mathematica. So I downloaded Mathematica for a 15-day trial, and I wanted to try the machine learning. And so I went to Kaggle, grabbed this NBA shot logs. Basically, this shot log is a CSV file that logs all the shots made and missed by players during the 2015 season. So I imported Mathematica is easy to learn. There's good documentation. Yeah, I imported the file here. This first line here, so it's running that CSV file, importing it, reading it line by line, and then just separate the header and the data in terms of the first line being the header, and after the first line all of it is going to be data. So now this line here associates the header to the data, kind of like this, and then once all of this is done, it should be like a table like this, like a data set, so it knows that this is the column. It's like a table, column and rows, using the header names. So now in order to prepare this for machine learning, we have to randomly sample the data in the data set. This is just like the standard 70-20-10 thing, like for train validation and test, but a little bit random so that it will just get the samples randomly from this data set. So after that, I use the index numbers for the train to get the training data, and the index numbers for the test to get the test data here in this variable. So after looking at the data, I decided that I would try to predict if the shot is made or missed using the shot number of the player, the shot distance, and the closest defender distance. So basically the shot number is so if a player shot like 10 times in the game, that's the incremental number that counts the number of shots he made during the game. So basically this is just mapping this values here to the shot result, and that's for the training portion. I just did it again for the test portion. And then once I have this, since the shot result is actually labeled made or miss, I translated that to if it's a miss, I think this is called zero nothing. Yeah, if it's a miss, I map it to 0. If it's a made, I map it to 1. So after doing all that, we have the training data that has been replaced, the test data that has been replaced, and then this is the magic to it. So in Mathematica, there's a classify function. So I'm just gonna go through this. So basically, this can be used to against many types of data, including numerical, textual, sound, and images, as well as combination of this. So if you actually read this documentation, there's a section here that says neat examples. So yeah, there's the examples in here, and then like practical applications. So this is one of the nice application of it. So I think this use the MNIS data for handwriting, and then labeled to the actual value of the image, and then it just called the classify function, and did a logistic regression. So in our test data set, I just say classify on the, call the classify function on the training data with the performance and load quality. You can actually indicate here as well like the method that you want to use here. So you can actually either choose logistic regression, Markov, random forest, support vector machine, nearest neighbor, or neural network. So that's pretty cool. I mean, in terms of like implementing a classification function for machine learning, it's just one line of code. That's pretty amazing right there. So I just let Mathematica choose for this one. So and then so basically this is trying to run the classify machine learning thing. It's trying to learn based on the data set that we provided. So this might take a while here as it's trying to do the learning. You can actually send this to the GPU as well. There might be there's a line of code that you can put in like at the top portion of your Mathematica notebook in order to send it to the GPU, so that it'll be faster doing like the machine learning function. Okay, so it's still running. Or maybe we could just do this. I'm gonna cancel this kernel right here, and let's do performance goal is, let's say, speed. So okay, so let's run that again up to here. Start at the beginning. So to rerun this because it's gonna try to because I canceled the kernel. Needs to read those data again, set up those variables, and before we actually get to the machine learning part of it. Alright, there you go, being populated. So where are we? So now try this again. Pick that up. Pick that up. Okay. So let's get the data. Let's get the test data. Map it. Map it. Replace the made or miss. Replace the made or miss. Now we are ready to learn. So yeah, so now it's running again. Alright, so now it's done. So it actually choose the nearest neighbor method in classes of 2 with the feature type of numerical vectors, and we have like 89,000 training examples. So this classifier function, we can actually refer to it. Here's one of the neat things that you can do in Mathematica. So I'm gonna try to measure the performance on the classifier function that it was able to model out of the training data set. So there's a function called classifier measurements. So reading this documentation, this would this object will have these properties that will measure the performance of the classifier. There's the confusion matrix, the precision and recall, and the F-score. So don't need to do it by hand, it's given to you. So now let's capture that. So now once I capture the measurements, the classifier measurement object, we can actually run through its properties. So in order to know what kind of properties are in this object, properties. So yeah, you can do that. Now this one. So this is actually getting the confusion matrix plot, which is this one. So it will do this. It will graph it for you so that you'll be able to see the precision and recall numbers. So like this one. So this is the actual class that it was classified to. This is the predicted classes right here. So like this one, so it's got like a precision of 0.835895. So that's basically this number here over here, and recall for this is 0.611 0.611261. That's basically this number here over this one. So, and then same thing here. This get like a precision of 0.35. So this one is actually this number here over this one, and recall will be this one over this one, right there. Precision. Okay. So yeah, this will all be given to you, and then the F-score, you can get the accuracy too as well, and rejection plot. So that's basically this one here. So just using the shot number, shot distance, closest depender distance, we'll be able to accurately predict 60% of the time the shot result, right? So let's try this. So let's predict something using the classifier function, right? So if I have a let's say I have a shot log that's this one. Let's say probably the shot number is, let's say it's my first shot, and then let's say it's a shot distance of 10, then closer dependent distance is 0. Let's try and classify this. So basically this is being classified as 0, meaning that it will be 60% be predicted as being missed, right? So now let's say just a bit away from the basket. Yeah, so the closer you are to the basket, the greater your chance of making the shot, right? So let's say if I have a defender like who's a bit away too as well, yeah, 60% of the time we should still make that shot. let's say I'm 0.6 away. So I'll probably just make it. So let's say I shot like 88. It's my 88 shot of the game. So I'm probably fatigued. I'm shot a lot of times, and I might not be able to make it like this. Like, let's see if you can still make this if there's no defender near you. Yeah, so you probably are so tired making that. So about, it's your 10 shot. Yeah. After 10 shot, you might still have the energy to shoot at like closer to the basket. So let's say average. I think this is in feet. Shot distance. Yep. Let's see. Data sets, discussion, description. What's description? I didn't really say here in the data set, but I think it's in. Yeah, this is probably it. So if it's my 10 shot, and let's say I shot from 30 feet like a 3-point shot, so I probably miss it. Let's say it's my second shot, third shot. Let's say it's just about 25 feet away. I'm not sure how far the 3-point line is. No defender near me. Yeah. So I think that's about it. So the accuracy is about 0.6, and yeah, the rejection rate of 0.99. So this is the rejection rate versus the accuracy graphs. Yeah, so that's pretty cool that you can quickly try things out for machine learning with just one line of code, and then you can let's actually try, see if we can prove this will give better result if we use a support vector machine. Okay. So, but now, yeah, so it will try to do the learning, but yeah, this might take a little while because it's using a different method, but I have a Roman scale of speed. Oh, yeah, you must age to avoid a restart or current dynamic of the can be made by using in the evaluation menu. Yep, I'll say I continue waiting. Because I probably have an evaluation, this is just a trial IDE. Continue. Alright. So now, what do we have here? Oh, it's still doing its stuff. I'm not sure what's happening here, but continue waiting. I want to wait. Where's my notebook? Probably a lot of things open. Oh. Well, yeah, so I think this is good for simply trying things out. And well, let's actually abort it, like when it pops up again. Yeah, oops, there you go. So now, alright, let's try that again. So this will probably take a lot of CPU time as it tries to train like 89,000 rows of data, it's trying to learn from it. So I think performance isn't really the real goal here. It's practically good for trying things out, but I probably would still write a Python machine learning thing once I try things out and determine. It's probably good for exploration, like in terms of like trying to determine like which variables are correlated in terms of trying to predict or classify things, right? Okay, well, yeah, it's taking a long time here. Alright, so let's just, I'm just gonna quit this because yeah, maybe I'll probably can upload this. Let's try another method one more time. Let's say I want Markov. Would that be? Alright, so now we have to just redo this variables here because we quit the kernel. Okay. 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 Mm-hmm. Go. 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 There you go. Validation and data enabled. Let's try this. Okay. Alright. So now I've used a different method for classifications to come Markov. And we can actually try and see if it performs better than our initial nearest neighbor. Okay. Alright, so actually it doesn't really perform better, so we got like precision went down from 0.8 to 0.5, but we have like a recall went down to as well a little bit. So yeah, I think the nearest neighbor thing performed really well, so now our accuracy is just down to 0.5.